Welcome back to lesson 3 of week 3. And in this lesson, we're going to learn about binary shift, which is how many computer processors do multiplication and division. So in this lesson, we'll briefly recap the position values, look at what binary shift is, and see how it can be used for multiplication and division. The position values of a binary number are powers of 2. What does that mean? Well, a power of 2 means 2 multiplied by itself multiple times. So 2 to the power 3 is 2 times 2 times 2. 2 multiplied by itself 3 times. And it's worth noting that this might surprise non-mathematicians. 2 to the power 0 is 1. In fact, any number to the power 0 is 1. Okay, so if a bit is shifted to the left by 1, it becomes 2 times bigger. So if a bit is shifted from the 2's column to the 4's column, it doubles in value. So shifting 1 to the left is the same as multiplying by 2 to the power 1 by multiplying by 2. Shifting 2 places to the left is the same as multiplying by 4 or 2 to the power 2. Shifting 3 places is the same as multiplying by 8 because that's 2 to the power 3, and so on. So multiplying by a power is the same as shifting that number of places to the left. So that's how we do multiplication in binary. We find the power of 2 that we want to multiply by, and we shift all the bits to the left that number of places. In the exam, you'll only have to ever multiply by a power of 2, though I will cover other numbers in a few minutes. So let's look at a worked example. Here's a binary number, and I'm going to multiply it by 8. So put the number into the position values. 8 is 2 to the 3, 2 to the power 3, or another way of putting it, 2 times 2 times 2. So we shift all our bits 3 places along. Okay, I just quickly did that for you. So, and let's work out the result to see if we've got the right answer. The first number is 25, the second number is 200, and in fact 25 times 8 is 200, so we got the right result. And division's just done in the same way. We find the power of 2 and we shift all the bits to the right by that number of places. So let's look at an example. Divide this number by 4. So there's the number in the grid. 4 is 2 squared, 2 to the power 2. So you know it, we shift 2 places. But this time we're shifting to the right because we're making the number smaller. And there's our result. And once again, let's do the working out to make sure that we've got the right result. The first number is 24, the second number is 6, and 24 divided by 4 is 6. By the way, in the exam, because time pressure is tight, don't stop and calculate your results in this way unless they specifically tell you to. Do the sum and move on to the next question. I'm doing it to show you the principles of it. Is it likely that you might forget which way to shift? Hope this will help you to remember. If you're multiplying, you're making the numbers bigger, and so you're shifting them to the more significant end of the byte. And if you're dividing, your number must be getting smaller, and so you're shifting right, the number's getting littler. Hopefully that helps you to remember. We taught last lesson about overflow, and of course overflow can occur. So if you do a multiplication so large that the bits fall off to the left, that is overflow again. You can also get underflow, and that's bits dropping off to the right. And when you're working with integers, that will happen if you're dividing and then the division is not exact. So if you divide 6 by 4, for example, and the result, you're trying to store the result as an integer, then you'll get underflow because 6 doesn't divide exactly by 4. You may be thinking, well, what if I want to multiply or divide by a number that isn't a power of 2? That will not come up in the exam, but it is actually quite easy to do it. You split the number down into powers of 2. For instance, you could split 6 into 2 plus 4, or 19 into 16 plus 2 plus 1. Every number can be created out of powers of 2. And then you do each of those binary shifts, and then you add the results together. It's absolutely straightforward calculation, but it doesn't come up in the exam. So that's just as a point of interest, because I know, although I'm not there with you, that some of you will be asking that question in your own minds. Different processors do multiplication in different ways, and some use binary shift for multiplication and division in just the way that I've shown you. They have special circuits that shift the bits along the available space by that number to do multiplication. Other processors only have circuits that do addition, and in that case they just add the number up lots and lots of times, and they have a little counter that counts how many times they've added it. And so to multiply 2 by 5, they'll just add 2 to itself 5 times. Different processors are designed in different ways, and partly it's whether they're trying to make the processor as small as possible so that it has as few different circuits as they can get away with. So let's just recap what we've learned in this lesson. A reminder that the position values of a binary number are powers of 2, and when we're multiplying by a power of 2, we shift the bits that many places to the left, and if we're dividing, we shift the bits that many places to the right. If you're doing this in the exam, show you're working, but don't waste time on what I have done, which is converting the numbers back to decimal. That I'm just doing that as extra practice and to show you what's happening in the number. Okay, so here's a test, and there are 5 binary multiplications and divisions to have a go at, and I'll give you the answers on the next slide. So pause the video now, try those numbers. It's really important that you get to a situation where you can do these numbers, do these questions. And there are the answers. You'll notice that I've done the questions in a range of different ways. Sometimes I've given the number that you have to multiply by as a word. Sometimes I've given it as a power of 2, and sometimes I've given it as a binary number. And the principle is the same in all cases, and I don't know what's going to come up in the exam, but I think you should be able to do all of those. Okay, so one more lesson this week where we're going to look at an extra binary principle, which is masking, which is the final thing we're going to do with binary integers.